Alright, Chapter 9, Review 1. I loaned my graphing calculator out to someone for the ACT, so you have to bear with me. I'm just using just a simple one. But anyways, number 1 says find each logarithm exactly. Well, since this has base, if there's no base, it's base 10. That's the exact same base as what's in your calculator. So all you have to do is go log 0.00001, and you can't see that, can you? Because it's, do it maybe over here. I just simply put that into my calculator and push enter, and I get -5. ln e of the -1. Again, you can put this in your calculator. ln of e raised to the -1, and I get -1. You also could have brought down the -1 to the front. Since it's a log and it's an exponent, we would have had -1 ln e, and remember ln e is 1, so it would be -1 times 1, which is also -1. Now this log is base to a different one. It's not base 10. So that one we have to set equal to x and then solve it out how we've learned. So I'm going to actually start number 3 up top. So I have my base is 9. Logs are what? Exponents. So that's my exponent of x is equal to 1 over 81. Now, you might actually be able to see what the answer is. But if you don't, that's okay. What can we do? We have an exponent, a variable, so we need to, yes, log both sides. So I'm going to take the log of both sides. I'm going to bring this x down. So I have x log of 9 is equal to log of 1 over 81, and divide by log 9. I throw this into my calculator, and I get -2. Alright, number 4. Again, we have here, what is my base? My base is 10. My exponent is x, and that equals this right here. How else can we rewrite the cube root of 10? You can write it 10 to the 1/3. And so x is equal to 1/3. Now, if you didn't see that, you could always say that it is 10 to the x is equal to the cube root of 10, and then take the log of both sides and do the exact same thing. Bring that x down. So you have x log 10 is equal to log cube root of 10, and then divide by log 10, and that also will give you your 1/3. So 5, it says find each logarithm to the nearest thousandths. So all they want you to do is to throw these into your calculator. So I'm going to clear it, and you can see that that's good. So you go log of 20.21, and that gives me 1.306. And now the next one, I clear that out, and it says ln of 233. I get 5.451. All right. So now this one we're rounding to the hundredths. So number 7. Number 7, it has e to the x plus 2 is equal to 34. Now, you can take the log of both sides if you want to, but I like to always do the opposite. So since it's e, I'm going to take the ln of both sides, the natural log. This is my exponent, so it's going to drop down. So I have x plus 2 ln of e is equal to ln 34. What does ln e equal? Yes, 1. So that means I just have x plus 2 is equal to ln 34. To get x by itself, I must, yes, subtract 2. So I'm going to subtract 2. So I have, clearing this out, I have ln of 34 minus 2. So I get 1.5, and it's going to round up to a 3. Number 8. So I still have an exponent in the top, so I'm going to take the log of both sides. So I can take the log of both sides. That x is going to come down. So I have x log 9 is equal to log 33. And then I'm going to divide. I want x by itself, so what am I going to divide by? Yes, log 9. Log 9. So I'm going to go log 33 divided by log 9. And that gives me 1.59. Number 9, I have right here, I have log base 4 of x equals negative 4. Logs are what? Yes, exponents. So that means my base is 4, my exponent is negative 4 equals x. Alright, so now I simply just put in 4 to the negative 4 into the calculator. So I have 4 raised to the negative 4. So I get your 0.0039, so that's 4. Now even that it said to the hundredths, we want to round it out because this was 0, 0, so you have to. Or if you have a fraction, you can say math fraction, and it will give you 1 over 256. So either one of those would work. 10. ln of what base? When we have ln, what's this base down here? The base is e. Yes. So now we have e to the negative 1/2 is equal to x plus 3. Since this is a number, we can throw that into our calculator. And then what do we have to do to get x by itself? Yes, subtract 3. So in my calculator, I will go e to the negative 1 divided by 2, end of parentheses, minus 3. That gives me a negative 2.39. The common log of a number is 1. What is the number? So we have the common log, so it says log of what number, and it says of what number is 1. So what is the base here? So that's where our x is. So our base is 10, our exponent is our 1, equals x. So 10 to the 1 is 10. Very good. And hopefully, I forgot about that. Better move that up. You might not have even been able to see that. Sorry. I better, just in case you didn't see that. On 10, I went e to the negative 1/2 minus 3 in the calculator. On 11, it was log of what number is 1 So then I had base, so it's common, so it's 10. Logs are exponents, so that's my 1 equals x. So x was 10. Sorry about that. Number 12. Number 12 says to write in logarithmic form. So since it's e, logarithmic form will be ln. Then base is down here, so you can put an e if you want. Right here is your answer, and that's approximately 3.401, because logs are exponents, so that's where our exponent goes. Here we have answer true or false. If false, correct to make true. So it says that log of 16 to the third divided by 3 equals this. Well, we know that's false, because what we have is we would have log of 16 to the 3, and when we divide them, because logs are exponents, so we subtract them. So log of 5, and then we would simply put this 3 out in front. So the final answer would be 3 log 16 minus log 5. So number 14 asks, well, when we subtract them, we divide these two numbers, which is true. All right. Number 15. For each of the properties listed below, write the name of the curve, either logarithmic or exponential, which is described. It has the range of all positive real. So the first thing that we probably want to do is to graph what each one looks like. So I'll just quickly sketch it over here. Remember that a logarithm looks like this, and an exponential comes here and it goes up. Alright, so it has a range of all positive real numbers. So range is my y. So looking at here, this would be exponential. Log is all positive, so this one's exponential. It has a y-intercept of 1. So we have here my y's. The only one that has a y-intercept is my exponential. And C, the y-axis is the asymptote. Well, on this one, your x-axis is your asymptote. This one is your y-axis is your asymptote. So that would be your log. All right, 16. Half-life of uranium-235 is about 7.1 times 10 to the 8 years. Suppose a 10-gram sample of this exists at the time that was before about 4.55 times 10 to the 9th years ago. Let x be the number of 7.5 times 10 to the 8 year period. All right. Let y be the amount of uranium left after x period. So write a formula that you can use for this. So that means you remember y equals a b to the x. Now a is the initial value, so it's 10. B is what's remaining, so half-life, that means half. And x will be your time. And we don't have to divide it by anything because it says that we're going to let x be the increments of that. So that's what we have of our formula. 17. Alicia wants to invest some money in an account in which interest is compounded continuously. So that means we're going to be doing what formula? Yes, PERT. So P-E to the R-T. If the annual interest rate is 5%, by what factor will her money be multiplied in a year? And round to the nearest thousands. So they want to know what this is. So that means we have e to the 0.05 and time is 1 year. So we're just going to, in our calculators, go e to the 0.05 and I get 1.051. So it is approximately, will be multiplied by 1.051. Number 18. How many times more intense is an earthquake with a Richter scale of magnitude 8.3 than one of 5.7? So remember, Richter scales are what kind of scale? A logarithmic scale. So what must we do first? Yes, find the difference. So I have 8.3 minus 5.7. So I have 8.3 minus 5.7. Gives me 2.6. Logs are exponents. So that means my 10.6 is my exponent. And what is common? What is the base of the common log? 10. So I have 10. So I have 10 raised to the 2.6. So that gives me 398.1. So about approximately 398.1 times. All right. Number 19. Number 19. The graph of y equals 1/5 to the x is at the right. 3 key points are indicated. Name 3 points on the graph between, we have 0, 1, so 0, 1 right here, and negative 1, 5 right there. So we want 3 points other than that's on the graph. So all it's asking you to do is to make a t-chart. And we have an x, y, and we have to pick numbers between, for my x's, between 0 and negative 1. So to pick numbers, maybe pick negative 0.25 and then maybe negative 0.5. And you can pick any numbers, but I'm just going to pick my by 25s. And then all you have to do is put this in your graphing calculator. So you're going to go 1/5 raised to the negative 0.25 and get your answers. So when you put in the negative 0.25, you get 1.5. Here we get 2.24. In this one we get 3.34. So those are your points. So negative 0.25, 1.5, negative 0.5, and 2.24, and my negative 0.75 and 3.34. Alright, number 20. Consider the function y equals log 6x. what is the domain of the function, graph the function in the plane, and state an equation of its inverse. Alright, well, the first thing I'm going to do actually is I'm going to graph it so we can see what the domain is. So I want to take it to exponential. So I have my base is 6, my exponent is y, because logs are exponents, is equal to my x. I'm going to make that t-chart, and I'm going to put in values for my y. So I will do xy, so maybe I'll do -1, 0, and 1. So I have 6 raised to the -1, which is 0.17, and then 6 to the 0, anything raised to the 0 is 1, and then 6 to the 1, so 6 to the 1 is, 6. Alright, so I'm going to plot those points. So I have 0.17, -1, 1, 0, and then 6, and 1 right there. I'm going to connect those points. Alright, so what is the domain of the function? Remember, domain is my x. So that means, is there anything over here? No, but it does start here, so it's all positive. And now it says state the inverse. Well, how do I find the inverse of it? I have to switch x and y. So I'm going to switch my x and y. So we have your 6 to the x is equal to y, or y equals 6 to the x. They're both the same thing, but that's what your inverse is. Alright, 21, last one. Recall the relationship between decibels and the intensity of sound. If the decibel level was increased from 125 to 175, how much more intense is the sound? So the first thing we have to do is, find the difference. So 175 minus 125, that gives me 50, and that's 50 decibels. Now, the question is, decibels. How many on your decibels, how many did it go up? What does decibel step by? It steps by, 10. So I have to divide by 10. So that equals 5 as my exponent. And what's my common base? My common base is 10. So I have 10 to the 5th. So 10 to the 5th is a 1 with 5 zeros. And that completes the review. Hopefully this helps. If you have any questions, please do not hesitate to ask. Hopefully doing this, you will be able to do your review too when you're given that. Alright, enjoy. Thanks for watching.